Assalamu alaikum. Once again, Sat Sri Akal, Namaste to all of my viewers. I apologize that due to some technical challenges, I was just gone off of my live Facebook, and I just noticed that it was disconnected. I'll just start this session again. As I was starting my first, the second session, sorry, that today is my topic again is exponents. And as I mentioned last time, the reason I'm keeping this topic for grade 10 as well, because in grade 10, uh, everyone who will be uh, going through their first session of grade 10 will involve the same topic of exponents. So this session will be combined for grade 9 and 10. All those individuals who are currently in grade 8, they can take benefit of this sessions as well, because right after summer vacations in September, they are going to start grade 9, and in grade 9 they will be going through these session again. Sorry. So we were discussing in my first lesson exponents. As I explained, there are two types of exponents. We call them positive exponents and negative exponents. And as you see, x square, this is a positive exponent, and x minus 2 is a negative exponent. And I mentioned we can make a reciprocal, and we can change like 1 over x square to make it a positive exponent as well. And I was talking in a few minutes ago that these exponents can be combined. We can solve the different problem with involving these exponents, but we need to make sure that the exponent which has the same base like x or y or z or a, b, c, any variable we are using, they can only combine with the similar base exponents. We cannot combine x to y or y to z. Yes, they can get multiplication, but when we are getting addition or any other operation on them, we need to be very careful. And I'll give you some examples. For example, if you are to say x, and inside you have x plus y, and say we have 2, and this is also exponent is 2. Now when we multiply these, remember this x multiply with x, because it has the same base, we can add their exponents. But in this case, when it multiply with y, it's a different base, so you cannot combine x to y, but yes, they can stay together. They can go like this: x 2 y2 plus this x can go like this and stay with y. So now, sorry. Now in this case, because the base is same, we can easily add the exponent powers. But in this case, we cannot add because the base are not same. So this would be x2 y2. In this case, this can change to x4, and this will remain like this. So this is a clear example that we need to be very careful when solving these questions, because the base is same, so we add their powers. In this case, the bases are not same, so we just kept them together, and they kept their own identity, and they were staying separately. So now I'll move to the next topic. So now we were discussing, we have done some of algebraic questions as well, which I'm not going to repeat again today. But now I will move to the next topic. It says relating algebraic terms to geometric representations and degree of a term. So now I can explain to you what term means. For example, it shows you right here. So in this case, let's say, and this is example. So we have algebraic expression which involves only just regular integers like 2, 3, 4, all these constant number. So I am going to say integers just like 2 minus 3 or 4. So that's one example. Then we have algebraic expression which involves integers with variables. So now we have combination of integer with variables. Integer with variable. So these examples you can say 2x or say 3y or any alphabets combination of, just like we said, 2x 4y. So these kind of expression where you see those integers like 2 3, these are also combined with variables x or y. In this case we have just a regular integer, or we can call them constant numbers. Then we have integer variable with positive exponents. So then we have integer variables. So I'm not going to write down, so I'm just saying integer variable with positive exponents. So in this case, we have, for example, 2x squared says 3y squared. So any kind of these numbers, then we have say 4y squared x squared. So all these numbers, now the difference you see, we are mixing integers with these variables, and these are also with positive exponents. In the same case, we can have with negative exponents. So I would say with the negative exponents, in this case, for example, minus x, then we have uh, sorry, minus 2 minus square 2, then we have say y minus 3, z say minus 2. So all these are the negative exponents. Then we have the next example is I would like to, we can again have a combination of integers with negative exponents as well, where you can say it's 2x power minus 2, or you can say 3y power minus 3. So we have different examples. Only integer expression involve only these numbers, only with uh, integers with those variables. Then we have integers variable with positive exponents. Then we have I can just say, let's say 2. So by adding 2, this combined another example of integers, variables, and negative exponents. You write down here, say 4, 3, anything. So the purpose of this is to make sure to understand that there are different type of expressions, which all involves, in some cases only integers, some cases only variables, some cases integer plus variables, integer plus positive exponent variables, and some of them are negative exponent variables. So now I'll go to the next topic and explain to you that there are different degrees terms you can call, and we have first degree terms. We have, and as I explained you that this is a term means that how we are going to write out this expression. First degree term, then we have second degree term, and then we have a third degree term. I'll explain you what are these and how you identify them and what are their roles when they are used in mathematics. So I'm going to go to this topic now. So as I explained you that the first one is first degree term, and obviously in mathematics the first degree terms always represent a straight line. So these terms are, and as I explained, for example, 2 or say 2x. So these represent a straight line because they are just 1 degree. So remember we were discussing previously exponents is 2, 3, 4. So those are their degrees. Like 1 degree is just 1. 2 degree means you write on 2. Cube or 3 degree is 3, 4, 5. So we can increase those degrees as well. Then we have a second degree term, and second degree terms always is two-dimensional. So this was the first degree. Now I'm talking about second degree. Second degree is like, say, x squared. Simple. So this is the second degree, or anything, for example, 2x squared, so these 2 degree always give you two-dimensional. Mean you have, this was a straight line, so this could be like this, x and x. So easy to understand is the first degree always represent a straight line. The second degree represents a two-dimensional figure. Now the third degree is again third degree could be x3, could be xy2, could be y2z, anything. So imagine these have 3 total d, because 1 degree, 1 is from x and 2 is from y, so make them together 3-degree term. So these are representing three-dimensional figures, and three-dimensional figure means you can have, for example, let's say cube. So that's x, x, x. So this could be x cubed. In this case, this could be x squared. And in this case, it was just x. So now from this, you can easily understand this is first degree, second degree, and third degree. First degree always represent a straight line. Second degree represent two-dimensional figures. And 3 degree represents three-dimensional figures. Now there are some examples. So let's do some examples which are given in this book, and I'll leave it up to you who are interested. Once again, I keep showing this book again and again. If somebody joined me just now, this is the book I am using for grade 9. And once again, the people who are for grade 10, this will be the book I'll be using for grade 10. So now I will take you through some examples for solving these first degree and second, third degree questions. I would request anyone who is watching this program, and feel free to give me a feedback, and if you have questions, because I also now turn on my Facebook, so I know that if there is any questions you have, so I'll be, I'll try my best to answer if I can. So now we have a question example which says a cylindrical drinking bottle with a base radius of x centimeter is filled with a liquid up to height of x centimeter. What will be the volume? Remember, volume is always a 3-degree term. So 3-degree term is it. The way it will work is that it says a cylindrical drinking bottle with a base radius of x centimeter. I hope that the students of grade 9 will still remember how to find a base of a circle, or the base area of the circle. The area of circle, remember, was pi r square or x square, whatever you like to say, because they are using x, so I'll just enter x, but let's say pi r square, right? So the pi value, 22/7, and r is the radius of the circle. In this question, they are using x as the area. So I am going to say the base area becomes x square, because our radius is x in this particular example. So now when the radius is x, now everybody knows the volume would be, what would be the volume? The base area into its height. Height is given as x. It says right here, the height is x centimeter. So now if my base area is pi x square and my height is x, what would be my volume of the bottle is pi x3. So this would be, and again, because it says x centimeter, so I am going to use as centimeter cube. The reason why I'm using centimeter cube, because there are 3 dimensions. So one was the base area, which become this x square. If I'm using centimeters, so it would be centimeter square. When I'm multiplying with their height, it becomes a centimeter cube. Now another example given, just to understand this. It says Todd's pencil case has a rectangular lid with the length of 25 centimeter and width of 15 centimeter. So now in this case, what would be the total perimeter? So let me just, or I'll just keep right here. Let's say, let me use a different color so we can differentiate. So in this case, rectangular case, and it says that the length is 25 centimeter and the width is 15 centimeter. So now the perimeter would be, obviously, I hope that grade 9 student, you know the perimeter is the total sides or edges. So that would be 25 plus 25 plus 15 plus 15. That will give me 50 plus 30, 80 centimeter. Now, if somebody can tell me why in this particular case, I am not using centimeter square. Again, this is just a straight measurement. This is one dimensional. As I remember, we said 1 degree, 2 degree, and 3 degree. This is a straight line. Remember the first, the line and category I explained you? In this case, up to here is 2 degree. This become a 3 degree. So I hope that this have clarified some of the topic of the first degree and 3 degree, second degree and third degree terms. In my next mathematics session next week, I will be discussing exponent laws. I'll just give you briefly what they will be. Exponent laws will be multiplication, multiplying power law, the dividing power law, and exponent of zero law, and power of a power law. So we are going to discuss these laws once we cover up these 3 topics. As we mentioned, positive, negative exponents, then there are degrees, and then the exponent laws. Then we'll go into the detail of solving these questions involving the mathematically exponents, and we'll divide, multiply, and open brackets, and there will be a lot of fun questions coming up. Once again, make sure your basic concept of exponents, understanding about their laws, understanding about their terms, first degree, second degree, how they can combine, how they can multiply with each other. Remember, if the base is same, then you can add their exponents. If the base is not same, they can stick together, but we cannot solve or combine their exponents. So those are some of the basics. Once again, when we go through this exponent law next week, after that we'll be in a good position to solve different types of algebraic expression, which will involve our terms of just regular terms, or we have first degree, second degree exponents, or we will be using these exponent laws. I hope that you are enjoying these sessions and you are learning something from these sessions. Feel free to send me any message regarding these mathematics classes, any feedback at 416-571-1163, or you can send me messages through my Facebook Messenger. If you still have any confusion on the presentation or you have particular question, I'd love to answer in my next week presentation. Thanks and have a wonderful weekend. Enjoy your day. After a long time, we are getting this good hard days. And all those who are celebrating Eid, happy Eid. Eid Mubarak to all of them. Today is my 29th fasting day, so I'll be celebrating with my family tomorrow. Stay home, stay safe, and enjoy your weekend.